Okay, welcome back. I'm trying to make these videos not too long. All right, so I made some stuff for you here, and you can see it on the screen. Um, so let's go to this one on the far left. And this is kind of like your homework with you, if you will. And what I'll do is I'll scroll in here, and I just want you to try to make this circuit. And what you'll see here are 3 ammeters. They measure current. So 1, 2, 3. And over here is a voltmeter. And they're oriented kind of awkwardly. Just get over it. I mean, it's the best I can do. But what I wanted you to see here is there's literally just a single resistor. And the color code kids are like, oh, brown, black, sorry, orange, black, brown. That's 200 ohms. And that's going to be in parallel with 100 ohms and 100 ohms. So what I want you guys to do is try to build this. I'll give you a pretty decent look at it. And pause and see if you can build it. And then I'll click Start Simulation. Okay, pause it. Come on. There you go. So I hope you tried to build it. And if I start the simulation, what you're going to notice here is that the ammeter that was put in series, I had to break the circuit. All the current, 20 milliamps, passes through that first resistor. But since these two guys are in parallel, and I know I had to wire it kind of strangely, but it's just for visually pleasingness, the current's going to split up evenly since we've got 2 equal resistors. Now, the 4 volts is how many volts are across this guy, which means there should be 1 volt across these guys. And if you do 1 volt divided by, that's right, 100 ohms, you're going to get to 10 milliamps. Again, the negative sign is because black is going first and red is second. I just can't get around that without flipping it upside down. I don't know if it just is what it is. So that's a nice little practice. Now it's pretty much like your homework. I would love it if you guys, if you built it, that's great. And if you feel happy. So I challenge you to stop the simulation and maybe change the numbers. Look how easy that is. So if I click, let's say this one, you can make it a little bit more messy. Let's say this is 300. And I can stop it there. And let's make this one different. So if this was 100, and if this was 100, let's make the top one, let's make it be, let's say 50. Ooh, how exciting. So try to build that. Think about it. This one's going to be a bit messier, but don't forget Ohm's law. And think about resistors in parallel. 1 over R equals 1 over R plus 1 over R. So pause it, try it, build it, predict it, and then I'll see if you get what I get here. And it's messier, but what you still need to see here is the current in the first resistor evenly divides up into 10 and 5. And if this is 4.5 volts, obviously this is a half a volt across both of them. Throw in more meters to verify it. Okay, now click this button here. Look how easy that is. I just want to quickly do a little bit more on the voltage divider. So look what I've made here. And you can pause it and think about it. But literally all I did was take this potentiometer, and which, if I click on it, you'll see here as I turn it, I'm always going to get something that pretty much adds up to, in this case, it's adjusting here, it's a slow. This is a 1,000 ohm variable resistor or potentiometer. So when I say voltage divider, it's literally taking the resistance and chopping it into 2 pieces. And because it's a potentiometer, it always adds up to some fixed value depending on which one you choose. So if I stop the simulation here, notice that if I click on it, I made it 1K. I can make it be anything. I can go to ohms here. Oh, let's be crazy. Let's do bye-bye. There's today's global word. So it's 800 ohms. I'm going to restart my simulation. And notice how it takes a minute here. This is not the fastest program, but it's free. You can't complain about free. So there you go. And so whenever we turn that dial, I just want you guys to realize that's what you're doing. You're just literally dividing that resistor up. And you can see how it's hooked up here. You're not going to get those weird values. So I'm going to zoom out. Now I'm going to come down here, and I'm only using the Arduino, by the way, because it's pre-wired and it's easy. It's like Costco. It's free, take it, why not? So same idea here, except look at how I have now 2 voltmeters. Back to our idea of voltage divider. All I did was take the same 1K resistor, and it's going to get divided up into 2 pieces. So as I turn the dial, notice here how the 2 voltages are going to roughly add up to the power supply, which in this case is 5 volts. You can turn it all you want. Now, in the projects you guys have been doing, we've only cared about one side of the voltage, like maybe the 1.9 or the 3.1. I mean, it's there for the taking if you want both of them. But whenever we have a sensor, it acts like this simple concept of a voltage divider. And, you know, we're just trying to take that voltage and then do something with it. So again, these things I have here, build them, play with them. That's really your homework. And I hope that you choose to check them out. Now, finally, I just wanted to show you this because we've done it way too much. And then since I have this cool program, I guess we need to like take a look. Here's the push button switch, your favorite thing on the planet, next to Chicken Tender Day. And what I've done here is I've got literally 2 resistors. One of them is, what's that, 1K, and the other one is 4K. That means what we have here is 5K in total attached to 5 volts, which is the Arduino. Don't forget, so if we look at the Arduino, we don't have a whole lot of choice here. Getting a little better at this, but it lags kind of like most of my StarCraft games, especially when I'm winning. So here's your 5 volts in your ground. The Arduino just has a convenient power supply, so that's what we're choosing to use. Convenience is always good. That's why 7-Eleven is so successful. All right, so now let's get this out of here because it's in the way. There we go. I just want you to see this button. Again, if you build it, have at it. So there's your orange, black, brown. There's your orange, black, yellow. And all I did here was I put a voltmeter over here because we've used the push button switch just to get a signal, all right? So if I push this, it's like, wow, that's 4 volts across this resistor, which means that's 1 volt. But also there's current only when I push the button, and there's no current here. And I also wanted you to see how what I've done here is I really want to make sure there's a rock solid 0 volts, especially when we choose to use logic. So let's say I just use a logic gate here, one of these puppies. They really want the inputs to be 0, not floating, but a firm 0 versus 5 volts, or high or low. So I just wanted you to see these. Yeah, get out of here. Let's see. And we'll delete you. Boop. Nothing personal. And there we go. So I stopped the simulation. We'll start it again. And just feel free to build these. And you can do this over the next 2 days. Build them, play with them. And when I say play with them, you can stop here. You can put in a different resistor and see how the current's going to adjust. We don't care too much about the current, but we do know the Arduino doesn't like huge currents. So that's why we're using, in this case, K, kilo ohms, versus just good old-fashioned ohms. And likewise, the voltage here, you can kind of think about it. And again, the values are they reversed on this one? I forgot. This one's actually, come on. Let's see if I got this one. Yeah, this one's reversed too, only because I guess here I have, don't have the same excuse. Here, I'll show you. I can stop it. I can get rid of this wire real quick. I can get rid of this wire only because moving them around is a pain. What I can do is take this little puppy here, move it over, let's say to, is that good enough? Yeah, it's good right there, so you can see it. Now I can tie this one to ground, which is as we're supposed to. And this one is the red. So now notice how red is catching sort of upstream, if you will, and the other one is now the black lead is actually getting what it wants. So now when I click start simulation, you'll get 4 volts that are positive versus negative. And the current's backwards for the same reason. And there's our milliamps. Sometimes it goes to micro, I don't know why, but that's 1 milliamp, which is a good safe voltage for the Arduino. Because each one of these inputs here, they do not like to source or sync beyond 30 milliamps. 20 is still kind of pushing it. 40 it can handle, but you're redlining it. Okay, so that's it for now. But pretty please challenge yourself over here in the upper left and try to build these and just tell me what you think. You're just going to get better at it. But the act of building them is going to make you think about it. And just listening to me is fine and dandy. But again, you get better at this when you actually do it. All right, so I survived the thunderstorm here. Stop the simulation. Let's see if I can get out of Zuma. There we go. I know they have these commands here that don't work too well. I'm going to stop the recording. So you guys have a good day. And if you work on this for the first 2 days, so Wednesday, Thursday, we're good. Then I'll kind of push you into some more coding. All right. Have a good one.